All right, thank you very much for the introduction and welcome everybody to this double presentation. So you get two for the price of one. And we're both going to be talking about digital twins for decarbonization strategies. And I just set a bit the frame of what we're working on, and then Chris takes over for the fun parts of showing you the game and what we can do with it. So if my slides would move. Yes, okay. So I'm going to introduce you very briefly the work at the Next Generation Cities Institute at Concordia and the tools we are building for cities and what kind of impact we expect with these tools and what is behind it all, and where we see contributions to make cities more sustainable and livable. So when I came here 4 years ago from Germany, I basically tried to find out who's doing work on cities in general, because I'm in engineering. My background is actually building physics, and of course, cities are much more than just the buildings and the physics. So I try to see who's working in very diverse topics around not just the built environment, but also the ecosystems around the built environment, on data, cybersecurity, mobility, and finally community engagement and design and arts. And I brought all these people together, and we founded the Cities Institute, where we tried to solve these problems that are never just one-dimensional in cities. And I talk a bit about it, and then you see what our approaches are to deal with these kind of wicked problems. So we build these tools. We also always aim to implement projects in real life in our own campus, Living Lab, but also we work a lot with the private sector and also the social sector around affordable housing to create zero carbon, but also inclusive and affordable settings in cities. And of course, nobody can do that on its own. We also try to find out where the best practices worldwide are taking place and collaborate with these partners. So for me, my work basically deals with the emission part. So we really still try to mitigate climate change, and that basically means to reduce carbon emissions. And Canada is still one of the biggest emitter per capita. So this is sort of a picture of lifestyle carbon emissions, so what every individual in the world uses. And Canada and the US, they emit about 14 tons per capita CO2 per year. And the sustainable goal for 2030 is 2.5 tons, and the real final goal is 0.7. So we have a long way to go. And as you see from the distribution of emissions, we need to deal with basically transportation and housing, but also the way we eat food, we consume goods, and what we do in our leisure time. So I think many sectors are involved, and this is actually not so easy to calculate, because every decision you take, whether it's type of transportation you use, the way you consume food, I mean, it's a lot of numbers involved. And we're trying to build these tools and just let it run in the background to make it basically easier to assess where these emissions occur. So, and what we did when I came here, we basically tried to look at the open data portals of a city. So you basically find a ton of data available on open data portals. So we didn't buy any of this data, whether it's the full geometry of every individual building, whether it's, of course, the road network, the power distribution network, the places where petrol stations are located, how waste is collected, where the trees are. So we don't have everything, but we have, for example, public trees in Montreal, and their exact location around the buildings. And with these tools, we can really model what happens on a very granular scale. So we can run a building model of every individual building and say what it consumes for heating and cooling. So these kind of digital, that's what I would call a digital twin, which is basically a model of a city, the infrastructure of a city. I mean, we start modeling also people, because these transportation objects that you saw moving around, of course, are, this is a model actually driven by from where to where every individual in the city moves. There are surveys every few years to find out what the origin and destinations of travel are. So we can then build a model and see how these objects move. And if there's too many in a certain street and we have congestion, the agents know how to choose alternative routes. So we can actually populate these cities with a lot of data, and that allows us to do this pretty detailed analysis of emissions. But of course, there's more to a city than just carbon emissions. And in fact, what most people are much more interested in are the other dimensions of sustainability, or what you would call an ecological city. It's basically how green is a city? Can you walk? Do we have neighborhoods where people can meet? So many aspects of a city, of course, are not so concerned about carbon emissions, but it's all related. So before I hand over to Chris, I just want to touch a few points of where a city layout has an impact on the well-being and health of people. And of course, this transportation topic, which is a big carbon emission source, has an impact on health, of course, because the more you walk, typically the healthier you are. But there are other aspects of walkability on health. So we use these tools and these digital twins to also calculate how walkable a neighborhood is. And the other aspect, of course, on health is the greening of the city. So the impact of green spaces in cities. They, of course, induce to more physical activity, but they have other health benefits as well. So the question is, does that all come together? So more walkable, more green, and then we have a nice city. Unfortunately, it's not that easy, because here you see a map of Montreal with the so-called walk score. So the higher the score, the more walkable the city is. And of course, downtown in the areas where you have a lot of density, it's very walkable because you have a lot of amenities. If you see the heat map, so here there was a car driving along measuring temperature. Unfortunately, these downtown areas are actually the hottest because there's not that much green in there, for example, and other effects, but there is not always a correlation between good walkability and biodiversity or greening in a city. So we need to solve these problems together, and we're looking at greening, especially in these inner city areas or in areas which are socially disadvantaged. In the same digital twin model, we can do all these calculations and scoring methods. So that's what the tools allow you to do. So we use them to plan transformation scenarios, but we can also assess thermal comfort, walkability, and so on. And I just want to one little point. Where are we in Canada in terms of walkability or density? And there are, of course, a few cities, the biggest city especially, that are pretty amenity dense. But as you know, and probably have experienced, there are many cities in North America and Canada, of course, which are not very dense. So and that, of course, is a problem for urban sustainability in all these cities where you basically don't live in an area with lots of amenities. You're often forced to use the car because there's just no public transport. And then another consequence of that is the carbon footprint of Toronto related to this low density and the higher use of private cars. Your per capita carbon emissions increase. So But as I said, the problem is complex. I mean, because it you might be in a downtown area, walkable, and you might think you're especially healthy, but then you don't have enough green and no access to parks or so, and then it's not as good as you think. So there's a lot of dimensions to look at. And the final thing I want to throw in here, we just did a study on food supply in urban areas. Was a big discussion during the pandemic. Whether we could feed at least the vulnerable population by community gardens. So if you look at the number of parks in Montreal, there's actually quite a lot, over 2,000, over 66 square kilometers, and community gardens, there are a few, less than 200 on a very, very small surface area, so you hardly see the little dots on the map. So we basically studied, well, what if you convert 20% of the parks to community gardens? How much people could we actually feed using the same data, the same digital twin that I showed you before. So we basically did a system dynamic model, because it takes time also to convert these parks, and you need some incentives and so on. So it's a complicated model. And then we looked, well, how many people are there below the low income threshold? And it's actually quite a few people, 560,000 individuals in Montreal, on the Montreal island, that have this low income level. And that means a lot of food per day. So we're talking about 167 tons of vegetables alone. And then we sort of try to assess, can we feed these people if we convert 20% of the parks to community gardens? And I don't want to go into the details here, but just to show you, it could cover 11% of the vegetable demand. That's, I mean, more than 50,000 people a day you could feed just by this very simple measure of letting people grow some food in park areas. The other thing, the final thing I want to say here, if you look at the cost, so after 10 years, that's what we estimated it might take to convert all this. The costs are only low if you rely on volunteers. As soon as you start paying people for growing this food, minimum wage, the costs are actually higher than if you would buy the same food in the supermarket, and you haven't really gained anything for the community. So, okay, I stop here because I just wanted to give you a very short overview of what these digital twins can do. And second use of the data is to engage citizens and to incite them to play with the data and have more fun. And Chris is going to talk about that in the following. And then we are, of course, happy to answer your questions. Thank you.
Thanks very much, Ursula. Thank you. And hello, everyone. Really happy everyone's tuned into this to hear what we have to say. I want to talk to you and demo to you this prototype that we've just recently created, built on top of using all the kind of the science and the modeling, the digital twins that Ursula's just been talking about, and show you what some of the things we're aiming to do with this tool. We call it City Player. And I think what's really interesting is maybe open up a bit of discussion with everyone on this call, certainly in the Q&A, about are there ways that this tool could be useful in the whole topic of environmental health, which is not the way we originally thought about this tool, but I think there's really interesting opportunities for that. And so that's why I'm super happy to have a chance to talk to everyone here. What is City Player? I mean, essentially what it is a 3D digital neighborhood, a real neighborhood that could be a freely downloadable, playable on a PC or a Mac to everyone that cares about that neighborhood, everyone that lives and works there. We'd want to make this a freely downloadable bit of software that anyone could then use to create kind of their perfect neighborhood. They could change the neighborhood digitally to be how they really would like it, for whatever for whatever reason, you know, to make it more walkable, to make it more healthy, to make it more green, to make it more, you know, social, whatever they feel is important to them. And the other thing about this software, well, the core reason for it is it also becomes a way to collect people's thoughts and ideas about what they would like in their neighborhood. And collecting all those ideas and then sharing them with the urban planners, the developers, the city, the people that are responsible for making decisions around the future of that neighborhood. In fact, we're looking over the next 2 years. We've just got letters of support from ARTM, the transportation group here in Quebec and in Montreal, and the Office of Public Consultation de Montreal, to look at, okay, what future plans do they have for the transport systems in the city, and could we kind of visualize those in a particular neighborhood and get people's feedback on what they think they would like from that transport system or not like. So that's kind of the high level concept, and very shortly I'm going to show you this software running for real. But then really, while I'm showing you the software, let's have a think about kind of how it could help this topic of environmental health. And the first thing that comes to my mind is, with a digital version of a neighborhood, with an understanding of all the data within that neighborhood, the traffic, the buildings, the trees, the air movement, the people, all the things that are there, activities, what would be indicators that the software, the game could calculate to try and sort of give people an understanding, if they make changes in the neighborhood, how does that affect aspects of environmental health? And then could we use this software to get people to talk about their own environmental health concerns or experiences? So that's another key part of the software. And let me stress that the software will be developed as a game. So you actually have something to play. You have some targets. So I'll show you more of that when we get into the demo. But this is a fun bit of software to play with, kind of like a sandbox, like a bit like SimCity. But in that context, people can be sort of exposed to different types of sort of environmental health issue, and then maybe they can talk about it and report it up through the game. And we can visualize perhaps different sort of potential health effects that might come as a result of planned future developments. That's kind of an interesting topic to think about. And lastly, I think while people spend a lot of time in this software, it's an opportunity to actually educate people about environmental health issues as well as sustainability issues. Because while you're playing, generally there's a good correlation between playing and kind of things sinking in and starting to learn things. You know, and that's what we want through our high levels of engagement. So enough of the slides. I should be able to exit out of here, and okay. Hopefully you can all see this. So I'm literally now dive straight into this prototype we've created of City Player. And what you're looking at is, actually this is an area around the Concordia campus in Montreal, the downtown campus. So we have St. Catherine over here on the right and Sherbrooke over here on the left, and some of these larger buildings are Concordia campus buildings. In fact, Ursula and I work in just this little building just over here. And this has been sort of 75% automatically created from various public data, including OpenStreetMaps and Montreal Open Portal data, heights of buildings, the road network, the terrain height, position of public trees, all that kind of thing. And it all comes together to give you something you can play with. Now, let's talk about some other things on the screen. So top left, you can see that we've got a whole bunch of indices of what's the environmental sustainability of this neighborhood. These are actually indices from the US and Canada Green Cities Index. So emissions and energy, water use, waste, transport, building use, land use, and air quality. And we just put those up as an example. Remember, this is a prototype. This isn't finished software. This is kind of a movie trailer version of the movie. This is kind of what we would seek to build over the coming couple of years. So we could change these to other indices that might be relevant to the particular use case. If we were doing a version of City Player that really wanted to engage the citizens of the neighborhood around environmental health topics, then we could put indices up here that were related to, as I say, environmental health indicators. And the software would be analyzing in real time the infrastructure of this neighborhood, the buildings and the traffic and the activities and the greenery, and calculating values for those indices. And then from the gameplay perspective, the player would then be given some challenges, like can you, in this example, reduce emissions from an index of 300 down to 250, or could you increase the overall sustainability or the overall environmental health of this neighborhood, from 300 to 350? So that would be like a goal. How do you do that? Well, this is where it starts to get fun. You see this panel at the bottom. Imagine you really can go in and make some wholesale changes to the neighborhood you're looking at. So maybe I could select on greenery, and I would be able to add and remove greenery, add and remove parks or trees or green facades. Maybe I could click on the roads here if that was unlocked, and I could add bike lanes or pedestrianize a street. What effect would that have on the environmental health of that street in terms of noise, in terms of pollution, etc. Maybe I could click on transport and change something around the mix of vehicles that are going through that part of the city, in terms of the mix of, say, electric versus petrol vehicles, for example. And what we've actually mocked up is, if I clicked on buildings, you see here, I could change the height of buildings, for example, and it gives me a little panel with all these +1s on, and it's telling me that if I added 1 story of height to one building, I'm going to have a positive effect on 4 of those indices on the top left. If I increase the height of one building, a residential building, I'm increasing population density, and that, in theory, would give us a better use of energy, a lower emission per person, a better land use, and a better building use. And I'll show you the way we see this working. I've clicked on height now, and now you can see every building. It tells me how many stories every building has, and I can literally just scan around here, and I will just at random, pretty much, I can shift and click. You see I'm selecting several buildings. I can do as many as I like. And I can say, yeah, I'm happy with that, and then I have a slider on the right here, and watch what happens when I move this slider. I'm instantly saying, hey, I'd like to just pull back a bit. I'd like to add or remove stories from those buildings, because it's a game, there's a cost to everything. So in the top right-hand corner, I've got 5,000 eco credits, but if I want to add these 8 stories to each of those buildings, that's going to cost me 640 eco credits, the number in red. But what do I get for spending that? Well, if you look at the top left again, you can see what it's telling me. These little flashing green panels, like how much on each bar, how much I'm going to improve the overall sustainability of this neighborhood by increasing population density. But just imagine, if you will, that we push this in the direction of environmental health, and these could be indices around air pollution, or they could be around thermal comfort, or they could be around the noise levels, whatever we might think are interesting indicators that this type of infrastructure change could affect. So I'm just going to click accept that, and now you can see all those buildings have instantly been re-rendered much taller than they are in reality. And then what you can then do is you can go and explore this city that you're starting to build. So I click on the explore button, and now you see the little green circle under my mouse. I can choose somewhere on one of these streets to go and explore. So let's dive in. So now I'm down on the street level, and it's kind of brought the streets to life with some representative amount of traffic here. Hang on a second. Okay, let me try that again. Okay, that's better. Let me just turn some audio on as well. Hopefully the audio is working across this webinar. So now I'm down at the street level, and I can sort of see what it's like with the changes I just made. So if I kind of look up and around at some of these buildings that I just made super tall, like this one, you know, I get a sense for the change to the profile of the skyline of the city, and I can see how it's affected the shadowing across the streets. And you can imagine if you kind of designed as you know, your environment to be very low profile or high profile, you know, you really get a feel for how that changes the sense of people, you know, walking around the streets. Now, the other thing that you can do when you're down at street level, this is where you can start to give your own thoughts about this neighborhood. So you see this funny little emoji staring at me. There's a whole bunch of those hidden around the streets. And if I just walk into him for a second, see what happens. So now the game is actually saying to me, what do I think of this little social space? It's actually an area in front of Tim Hortons, just around the corner from where we work. You know, we've designed these feedback points very much around urban planning questions. Like, for example, this is like a social space. Where do you want your social spaces? But again, from the point of view of environmental health, you know, maybe we'd be asking questions about the layout of the city with sort of environmental health issues in mind, rather than just urban planning ones. But the principle would be the same, that, you know, we could let the player focus on these different areas, and then in a very simple way, just say, you know, maybe I really don't like this area at all. Just click on this emoji. I get some eco credits to reward me for making some feedback. And then I can actually type a comment, maybe say, you know, this area is always clean. I would never sit here. And send that feedback. And this feedback will be all collected via the game up into the cloud and made available to the stakeholders of the city. So the urban planners involved in taking decisions. It could have been a question about transport, could have been a question about air quality, could have been a question about safety. But the point is, it's kind of a fun way to get your feedback. And we've rewarded you with those eco credits. So the more feedback you give around the city streets up to your neighborhood, the more eco credits you earn. And remember, that's what you use to try and hit those sustainability goals, and use them. You spend those to make changes to the neighborhood. So I'll just exit out of here. Now, the other thing that we can do as we're walking around is I'm not limited to these kind of emojis to give feedback on predetermined questions. I could just look anywhere, and, you know, maybe I want to give some feedback about this intersection. And what I can do now is I can take a photo, save it to my photo album. And then if I pull up my photo album, here we go. Let's just find the photo we just took. There it is. And then I could say something, you know, this intersection is always so busy, you know, I wish this area was pedestrianized. If I can spell. Okay, so we want to explore as many ways as possible of getting sort of user feedback into this experience. The other thing we can do is, I'm going to do that same thing again, but if I go to explore, there's this little bar at the top, and I can actually change the time of the day or the night. So let's put this more sort of early evening. And now if I fly down, you'll see, you know, the sun is lower in the sky. and some lights start to come on, and it just gives a very different kind of look and feel to the environment. And one thing I just want to call out as well is we literally built this prototype you're looking at from scratch in 4 months with 4 computer science undergraduate interns at Concordia and myself. You know, there's a lot more fidelity and a lot more features, a lot more richness we can add to this. But really, this is kind of a proof of concept done quite quickly. You know, it was really just trying to take an idea and bring it to life. But it's not, oops, there we go. Okay. So another one last feature that I want to show you, which is very interesting, is you can actually play a different character in this environment. So if I click on this button here,
First day of class. I sure am excited, and I've got 4 minutes.
okay. So the
I don't want to be late.
The idea is that you can play different characters, and
Let's check the map. Follow the red pointer.
this is Kate, and she needs to
Okay,
get
let's go.
class. She's teaching class. She
I'm
needs
in
to
a
get
really
there in a
good
few
mood
minutes.
today. Let's try to keep it positive.
Okay, now she's just told you she's in a good mood, and the little green bar at the top left is a happiness meter, and she's going to respond in real time to how she's experiencing these city streets. So I'll just give you a very sort of direct example. If I just walk her into the traffic, she is not at all happy.
Oh, this is very scary.
She can't get her back into the sidewalk, and her happiness meter is just starting to burn down. So, you know, you've got to treat her as you would, you know, if you're walking down the streets, you know, and make sure she, you know, she looks after herself. Now check this out. So as I'm walking down here.
Quite a nice touch of nature.
Okay, so she likes greenery. She likes any streets where there's a lot of flowers and trees, and you know, and that's just generally increased her well-being, her state of mind, and the happiness meter now is glowing and it's starting to build up again. So that's kind of cool. So you can imagine this mechanism for showing how individuals are responding to the things that are happening around them, expanded beyond, you know, just whether someone likes trees or not. It could be about how safe they feel because of, you know, how well lit or not the environment is, about how they're feeling about whether there's a lot of traffic around them, or there's it's too busy with people, or there's not enough people. And we'd like to have a range of different characters that you could play to a range of different demographics. You know, what's it like to go around in a wheelchair, for example, or with some impairment? How is the environment feel from that perspective? Anyway, I'll just keep walking. Kate, the whole building is over there on the left. That's where we need to get to. You can see in the top right, we've just got a couple of more minutes to get there.
Oh no, I don't have much time left.
So she doesn't like being by the trash. So whoop, let me use the site.
Oh, what am I doing?
Okay, I can cross here. There we go. Okay. So as I say, my question, or sort of my thought I'm trying to share with everyone is, how do you use this fully interactive sort of 3D version of an environment to bring environmental health topics to people's attention and to get their feedback on them, and what kind of changes can people make to the environment, to the infrastructure, that would then have a knock-on effect to those environmental health issues, and sort of visualize those in this game kind of experience.
Quite a nice touch of nature.
Okay, so I'm just about to finish this mission.
I'm here early.
Okay, I've got her to class. That's all good news. The game then tells me, or it rewards me first of all with a whole bunch of eco credits for successfully getting there. Again, that's what I use to make changes to the neighborhood. And it tells me what she liked and what she didn't like, you know, during that little mission. So let's just go back to here. How are we doing for time? Yeah, cool. So that's kind of, you know, a real sort of a look at the prototype we built. We've now moved on, and with the last few months, we've started to add some more features, looking at another area of Montreal, Chinatown, and looking at some of the cultural issues around Chinatown, around building redevelopment, putting new buildings into empty lots, for example, and how does that affect things. But we're really looking for other opportunities to collaborate in other ways, in other domains, and I think the environmental health one is a very, very interesting one to explore. So I'll stop sharing, and maybe we can open it up to some questions.